All right, my name's Ted Skinner. I work at Splunk, I guess now owned by Cisco. Been there coming up on 10 years soon. And so this is my talk, just looking at, and we covered this topic a little bit earlier today, but sort of bridging that, the host and the network connection when we're looking at data. Particularly looking at like fileless Linux attacks. So just a brief look at the agenda here. So this talk for me started earlier in the spring. I was doing some SAN studying, working on the Linux forensics cert, and I attended this conference a few times, a favorite of mine, and was trying to figure out how can I kill two birds with one stone? How could I get a talk accepted here and dig into things I'm already studying? So one of the topics that I was digging into is how attackers often live off the land using tools built into the Linux OS to accomplish their goals. Attacks using these tools are tough to detect because of the legitimate administrative usage of them. And a lot of times when we do make detections for these, they're wrought with false positives. So, I was thinking hard about it. Could I use Suricata to sort of, take a look at these detections, give them more context, reduce the false positives, and then give us some higher fidelity detections for these living off the land attacks? And that question for me is where this whole talk started. So to highlight the problem, there's been a rise of these fileless Linux attacks. These fileless attacks are increasingly common in Linux because they don't need to write binaries to disk. Everything runs in memory or use some native system component to launch the attack. So historically, Linux has had less security tool coverage than Windows. So they're attacking Linux systems to avoid the visibility, not necessarily because Windows is harder to attack. So I want to dig into a handful of real-world examples, some of which I try to look at here. First of all, attackers can run reverse shells, right out of Bash, the native scripting shell. And then we've got crypto miners, or really malware in general, can be launched through some native devices, dev SHM or proc shell mem, to achieve their defensive evasion by executing without storing the payload on the physical disk at all. For those not familiar with the execution from dev SHM, it's a shared memory space, temporary amount that's usually writable by default and typically has execution permissions. Adversaries can, put downloads there, write malicious scripts or binaries into this memory space and execute them directly. And since data resides in RAM, when reboots occur, they typically just disappear on reboot. And then looking at proc self-mem, this involves a Linux system call, memfd create, and what that does is it creates an anonymous file descriptor, tough to say, in memory that can be used to inject and execute code. The memory is even stealthier than using dev SHM because there's no temporary file storage that's visible in the file system for this. You can also natively use base 64 encoding right with the operating system. And then the last example I have here is using environment variable, the LD preload, and that's used by a dynamic linker to specify shared library objects that get loaded into the process's address space for any other standard libraries. So these shared libraries can load malicious code into legitimate processes, so hide them there, or hide files or network connections by just overriding the open and read functions, creating backdoors, or even logging credentials. So the bottom line is these attacks don't really leave any artifacts, so there's nothing to hash, nothing to scan, very little bit of persistent evidence, if any at all, on the endpoints. Just calling out easy specific example here, just showing we can use bash natively to write a reverse shell. And again, these are hard to pick up on because admins do this kind of stuff all the time using bash for scripts and things, so it's easy to hide among legitimate traffic that's occurring. And we have a tough time looking at these if we don't have the correct telemetry in our environments. So we've got two types of telemetry. Again, I think we've talked about this a couple of times. We can look at what's left on the host, and we can look at the network traffic. So if we're only looking at the host data, the types of things we miss are encrypted C2 traffic we don't get to see because that hides on the network. It's not visible. Lateral movement over SSH, that looks like typical administrative activity. So again, it's something we missed. Crypto miners talk over TLS, so again, completely invisible from the host. If we look at the network only, file set execution, user commands, privilege escalation, sudo abuse, that stuff all happens on the host. If we focus on the network, we miss that there. Local privilege escalation exploits, again, produce no obvious network artifacts, and attackers can disable logging on the host, which make them invisible. So my answer from digging into this is that our mature SOC architectures, we need to require both host and network telemetry. So what I dug into, in my studies was using Sysmon or Sysmon for Linux or auditd, because and we can do similar things with Windows, but I focus on Linux just because of my studies this summer, to take a look at process execution, commands, file changes, and then relying on Suricata or Zeek. And again, I focus on Suricata since I was looking to put together a talk for here, to take a look at that C2, DNS tunneling, TLS metadata, lateral movement. And SIM is my specialty. You can use scripts and things to tie them together. Got a couple other ideas sitting in the crowd this week. I need to take a look at the community so we've got a community ID in Zeek and Suricata. We don't have that on the Sysmon side. Did a little bit of research, and it's going to be a future area of study for me, but can generate a similar thing on the SIM side. Take a look at the network tuple in the Sysmon Connect events, as well as the Suricata data, and look at tying that stuff together. But typically I'm looking at using the SIM to correlate and join that host and network data to look at the full kill chain of the events that are occurring. So what's useful is we look at the network data, we can see where things are occurring, what's on the wire. What we miss is that user context. We also miss sort of the process launching, what's causing the network traffic, and that's what tying these things together is going to help show us. So I broke the use cases I was looking at into 4 major categories. So I dug into these, applying this blended strategy to each, and so looking at the host-based telemetry from auditd or Sysmon, I tried to work through both. They show slightly different things. I did find auditd useful because we also get that audit ID, so we get the user context of what actually launched an executable, but then we also get who originally logged into the host. We don't really see that in the Sysmon stuff. But the advantage of using Sysmon is if you've got a hybrid environment, you can monitor your Windows and your Linux, and it looks similar. It's easier from a log aggregation perspective. And then also looking at those Suricata signals to tie these detections together. So first grouping, I was looking at reverse shell setup, and I do have a GitHub that I'll visit at the end of this that I've got a lot of the logic outlined, some of the detections I put together. But here I was using auditd rules to log the exec VE of suspicious programs that are going to connect via socket syscalls made by those programs, that's what's going to create the reverse shells. So the Sysmon for Linux rules are focused on reverse shell setups via either netcat or just interactive bash. That's what I focus on in these use cases. And then looking at any suspicious process create to look at odd parent-child chains and things of that nature, and then using network connect events to catch the actual outbound dial out, and then using Suricata to look for reverse shell commands moving in clear text and spot like known banners and strings being sent in the interactive sessions. I'm not sure how readable that is, but just wanted to point out some of the common banners and strings you might see in the different shell types that we're looking at, or that I was looking at. So the next class of things I was examining is looking at post-exploit detection using JA3. And as I learned yesterday, apparently I need to look at JA4 as well. I was a little behind the curve there. But so in summary, looking at auditd, so when we look at just auditd and Sysmon, you can't see the J3 because the host doesn't look at the TLS handshakes, so we can't natively match a hash to pure auditd logs, but we can still build a clean, repeatable detection. So what we want to do here is let the network sensor, either Suricata or Z, compute the JA3 and then flag a watch list on the ones that we're interested in. Again, I'm looking at using a sim to tie these things together, but you can create a little helper script within auditd to look at a watch list. But we want to use Sysmon for Linux and auditd to capture that host context, the who, what, where, and the processes that were used to launch these things, and then correlate the two in the sim is the approach I took. Suspicious file downloads. So in summary, I looked at instances of using curl and wget to go get risky file types, or things from suspicious TLDs, and then sort of write that behavior from curl and wget to get risky file types, whether they're zip files or debs or shell files. So, but continually applying that same approach of we want to combine the host and the network traffic story. So exfil via HTTP. So in summary, why these work. Exfil often uses methods that imply uploading, like either put or patch, or the other thing I looked at after some research was uncommon web dev verbs. So these are unusual in most environments and commonly correlate to write operations to remote servers. So I was looking at checking for a body like content length catches for when data is being pushed. Large posts are typically a classic signature of bulk data leaving a host, looking dumps, archives, whatever it might be. And then the header base size checks they're cheap to do, regardless of TLS or not. So we're inspecting the request from the client to the server side before encryption on some sensors and after decryption on proxies. The other thing I was looking at in my use cases was multi-parts with file names equals. I was seeing that this was a strong indicator of file uploads via web forms. This one here. Okay, so Unfortunately, the demo god's not smiling on me very well. I did lose connection while I back home. I did think ahead and do a recording. I may come back to this to show what some of the logs look like. I think my time might be served a little better actually jumping out to my repo here. Oh, too far. Guess I can make that quick and just show. Come on. Let me see here. There we go. All right. So I did make this public on Sunday, and I'll get to the link to you so we can share it. I think. So what I did was I broke out each of the different use cases, and then I had some common stuff here. Let me go into the exfil just to give an example. So I have so I've got readmes on each of these things, discussing the auditd rules. That is not. Hang on a second. I need to pull this over. Sorry, you guys aren't looking at what I am. Let me hop out of here. Okay, cool. All right. Let me see if I can make this a little bigger. That's not helping me. Sorry, I am horrible with a touchpad. Is that readable, or do I need to make that a little bigger? Yeah, let me work on it. Is it shift? All right. Okay, cool. So I want to put these out there because one of the gripes I used to have a while ago, particularly when I was first starting out, is you come to these conferences, everybody has these really awesome ideas, but it's really hard to replicate and go back later because you got a lot thrown at you. So I wanted to remedy that for my own poking around and research and try to put together some of the things I was working on. So for each of these use cases, I've got the auditd policies I was working with, and then what I tried to do is, detail some of the logic, like why these work, any extra notes, even implementation, how you get the rules in for those folks that are not familiar with Sysmon, for those who are not familiar with auditd. Out in the root of my repo, I've got some basic policies. So I've got, you can lay down multiple auditd policies. So I put a basic one that's got, your main baseline that you'd want on most any auditd implementation. And then I did a similar thing with the Sysmon policies. So you can't have multiple Sysmon policies. So you have, so what I did was, there's two approaches. You can either just test each use case, or I did make one master Sysmon policy that's got all of the rules built into it. The master policy I've got out in the root, and then each of the appropriate ones I've got in the repo itself. And then I also have the Suricata rules for each. So I've got a rule file itself, but then again, I wanted to try to provide a little bit of explanation. So with each of the rules, be careful with copy and pasting. As I learned, I don't do Suricata every day. I'm more in the sim space. So I did have some bumps in the road. I was working on it. Thank goodness for test mode of Suricata. I can't tell you how many times I ran that over and over again as I was trying to get these in my lab. But so just putting together notes as to why I took this approach, what the explanation with each of them is, why, they should work. any type of things that need to be done to the, or that I did with the Suricata configuration. And then also some safe offline tests. So these are the types of tests that I did in my own lab, just spinning up a simple web server so that you can send the requests over, verify they got picked up in each of the signatures. And I did this with each of these cases. I won't belabor all of them unless anybody's super interested in going through all four, but tried to include some tuning tips. I wanted to make this repeatable for anybody that was interested in digging in this as well. And this conference was really helpful even for this research because I've already got a list of half a dozen future bits of work for here. So when I look at JA4 stuff, I actually want to look at playing around with the community ID a little more. I consider most of these detections pretty straightforward and basic, so I'd like to get a little bit more, see if there's ways to get a little bit more nuanced with them and expand the use cases. But it's, not being my day job, I gotta pick and choose my battles, but I see this as being an interesting space to continue working. So that is all I got.